Welcome back, everyone. Today, we are jumping right into a stress-free, guided tour of modern cloud data platforms. If you've been feeling, well, maybe a little overwhelmed by the sheer scale of modern data architecture, you're exactly in the right place. We're going to demystify how these systems are designed from the ground up to handle today's massive data explosion. We'll break it down piece by piece to make the complex beautifully simple.
Okay, so here's our roadmap. We're going to cover the 3 V's of data, the overall data platform solution, and then walk through the 4 core layers: ingestion, storage, processing, and serving. Let's dive right in.
First up, Section 1, the 3 V's of data. We really need to understand the growing pain points of modern data infrastructure.
Now, you've likely heard of these 3 V's: volume, variety, and velocity. There's just this massive, relentless increase in the total volume of data out there. Plus, we're seeing a huge shift in variety. We're moving way beyond purely structured database tables and getting into messy, semi-structured formats. Think user click logs, social media JSON feeds, or even raw images. And finally, velocity. Data is arriving faster than ever, transitioning from those slow, old-school nightly batches to constant, real-time streams. But here's the real kicker, the AI effect. Artificial intelligence and advanced analytics demand all 3 V's simultaneously. They want massive volumes of highly varied raw data delivered incredibly fast. It creates this intense trifecta of pressure that simply overwhelms your traditional data warehouse. Moving on to Section 2, the data platform solution. Let's talk about escaping the limitations of traditional architecture.
So here is the fundamental shift. Traditional data warehouses tightly couple storage and processing. If you want to store more data, you're usually forced to buy more processing power, which creates rigid constraints and, frankly, very high costs. But the cloud data platform introduces a loosely coupled, layered architecture. By completely separating storage from compute, you get elastic, cost-efficient scaling. Essentially, you stop paying for idle processing power just to store massive volumes of historical data. And this architecture right here provides the perfect blueprint for our guided tour. The entire system is broken down into 4 loosely coupled layers: ingestion, storage, processing, and serving. Because they're loosely coupled, they can communicate through well-defined interfaces without relying on the internal mechanics of each other. It's really the ultimate blueprint for modern, cloud-scale flexibility.
But looking at that whole setup raises a pretty critical question. How do we actually get the data into the system without breaking it or losing its original integrity? Before we can process, clean, or analyze anything, we have to securely capture it. And that brings us to the very front door of our architecture.
Section 3, the ingestion layer. This is all about securely capturing data from diverse sources.
When we talk about ingestion, there is one rule you must absolutely never forget. The golden rule of ingestion is absolute preservation. Seriously, do not modify or transform the incoming data. We keep the data exactly as it arrives in its completely raw format. Why is this so crucial? Future flexibility. By keeping it totally raw, we can always track its lineage, or we can just reprocess it later if our business rules or our analytics needs suddenly change.
A modern platform has to handle 2 completely distinct paces of ingestion: batch and streaming. Batch ingestion runs on periodic schedules. Maybe it's grabbing files or querying databases, and it sends that data to slow storage. Streaming ingestion, on the other hand, is grabbing one message at a time from message buses or change data capture tools and firing it directly into fast storage. By treating both batch and streaming ingestion as first-class citizens running in parallel pipelines, we prevent a ton of technical debt and ensure the platform can handle literally any speed of data you throw at it.
Next is Section 4, the storage layer, persisting data efficiently for both the short and long term.
We actually divide the storage space strategically into 2 areas. First, we've got slow storage. This is highly cost-effective object storage like AWS S3 or Azure Blob. It's optimized for massive files, batch processing, and keeping long-term historical archives for years on the cheap. Conversely, we have fast storage. These are message buses like Kafka, optimized for low-latency, real-time streaming. Fast storage generally only holds onto messages for a short, predefined window. It's really all about putting the exact right data in the exact right place to perfectly balance speed and cost. And underpinning all of this storage is the incredible concept of cloud elasticity. Elasticity is the ability of cloud vendors to automatically allocate only the amount of storage or compute you currently need. This is a massive game changer, right? It completely eliminates that old, incredibly stressful practice of over-purchasing physical hardware just in anticipation of future data spikes. No more sweating through Black Friday hoping the servers hold up. With Elasticity, you ensure you only pay for exactly what you use.
So now that we have a massive volume of raw data safely stored away, how do we actually make it useful and accurate for the business? Because let's be honest, raw data is kind of like unrefined oil. To actually fuel the business and drive decisions, it needs to be carefully refined.
Which brings us to Section 5, the processing layer. This is the engine room where business logic and transformations happen.
To keep things organized, we methodically move the data through 3 physical zones in our cloud storage. First, it hits the landing area, totally raw. Next, we use processing tools to move it to the staging area, where the data gets cleaned up, standardized, and deduplicated. Finally, it's moved into the production area. Here, your specific business logic is applied, and it becomes a finished product completely ready for consumption. And that naturally leads to our next step. Once our data is fully processed and refined in that production area, how do we get it into the hands of the people and systems that actually need it? Processing the data is really only half the battle. The true value is realized when it finally reaches its destination.
Section 6, the serving layer. Delivering curated data to various consumers.
Because we've structured our platform into distinct layers, we can easily serve drastically different needs. If a business analyst needs a structured SQL dashboard, we serve them through the cloud data warehouse. If a data scientist needs to run massive machine learning experiments, well, we give them direct data lake access to those raw files. For a mobile app requiring millisecond response times, we use in-memory caches. And for operational systems needing continuous updates, we push real-time streams. It's one unified platform, but with multiple, highly optimized delivery methods. And quietly running above all of these layers is the orchestration and ETL overlay. You can think of this as the essential air traffic controller of your data platform. It beautifully and mostly invisibly coordinates the data movement, manages the complex dependency graphs, and ensures every scheduled job happens flawlessly, automatically handling any failures or retries across all of those decoupled layers.
To sum up our journey today, our sources capture it perfectly. The foundation for every modern analytics program is a cloud data platform where data of all types can be ingested and processed at any speed and delivered to users in a manageable, scalable, cost-effective way. Ultimately, successfully implementing this layered architecture transforms your raw, chaotic information into a highly scalable engine for insights, predictions, and automation.
So, I'll leave you with this provocative thought to ponder. Does your current data infrastructure hold your business back, or is it a fully layered platform ready to scale with your most ambitious analytics goals? Take a moment to reflect on your own data strategy and consider how a modern, layered approach could unlock entirely new possibilities for your organization. Thanks so much for joining me on this explainer, and keep learning.